Well, thank you very much all for coming. My name is Tom Soderstrom, and I am Director of Chief Technologist for the public sector globally. Before this, I was Chief Technology Innovation Officer at NASA's Jet Propulsion Laboratory. So I would say my heart is still in space, but my brain is in the cloud. So that's me. And Buffy?
Yeah, hello everyone. My name is Buffy Wovoda. I head up the solution architecture team for the Aerospace and Satellite Group at AWS. The Aerospace and Satellite Group was started 2 years ago at AWS specifically to focus in on the space economy, the space industry, and how AWS can help the space industry thrive. Today we're going to be talking about some of the themes that we've seen over the past couple years in terms of the space industry and how AWS and its technology can really help the entire community make humanity involve.
And I'm just curious about you all. Who here is working in space today? Okay, it's about a third of you. Well, yeah. Who's interested in working in space tomorrow? Many more of you. Well, that's perfect. Our
Excellent.
work here is done. So
in terms of an agenda today, first off, we're going to focus in on space itself. What are some of the big questions that only space research can answer? We'll talk about some of the themes that we're seeing with the new space economy, some of the technology trends that we're seeing. But as Tom mentioned, then we really want to focus on you with this call to action, because it's all of the new ideas that are going to continue to drive the industry and going to continue to drive what we can do as a human species using space as our background.
So we'll start with the big questions. These are the questions that children have asked their parents for millennia, in fact, probably for the 300,000 years we've been on this earth. And these are the big questions. How do we protect Mother Earth? How do we divert an asteroid? And you can see them. But maybe most of all, are we alone? And if we're not, what do the aliens look like? So curious, in this audience, who thinks we're alone? Who thinks their life outside of Earth? Wow. Okay. If I had asked that a year ago, half of you would have raised your hand. 2 years ago, a third of you. So it's fascinating. And of course, you recognize the blue marble. 1972, one of the most frequently used images. And I've met several astronauts and I've talked to them. And I said, when you came back, what did you think? And they go, it's a very fragile place. Don't understand why we have wars. The outside, once you're outside the orbit, it's pretty scary. So now with the blue marble, 40 years later, we can see a lot more detail. We can see a lot more detail because there is a lot more interest in space. And that's essentially what we're going to talk about. 40 years from now, it's going to be an amazing picture. So what if we couldn't save this planet? Do we have a place to go? So what's the probability of an asteroid event? Bennu is coming back every so often, and in 300 years, there's a probability of 1 in 11, the same as flipping a coin and getting it heads up 11 times in a row. So no need to worry. But we have to worry about sustainability of our planet. I think we may destroy it from within if we're not careful. So, but if we couldn't find it, is there a place to go? And this is really a remarkable story. We have TESS, the terrestrial planet finder, and we have other extrasolar planet finder. An exoplanet is something that orbits its sun, just like we orbit our sun. And they've detected 28 so far, except it's now 55, so that are Earth-like. 20 of those are about the size of Earth. They're just kind of far to get to. The closest one is 4 light years away. With current technology, it's going to take us quite a while to get there. But we're starting to think about it. And the way they find them is you look at one spot in the sky at the same time for a long time, and you can see planets where, you can see a sun where there's a little dip. And that's probably a planet orbiting it. So what do you need to do that? Lots of compute power, lots of telescopes. And anybody, we'll talk about that in a second. So it's the life on Europa. What's interesting, Europa is, it's a moon of Jupiter, and it's covered with ice. What's interesting is there are no craters, because there's now water, there are ice lakes inside the very thick ice sheet, and there's energy. So when a meteor hits, it just evens out again. Water, energy, could mean life. It's probably the most likely place in our solar system to house life. And the Europa Clipper, NASA's instrument, anything is an instrument or a robot, it's a satellite. And it's going to orbit, look for a landing place, and sometime in the future, a lander will land and maybe melt itself down into the ice lakes or go down and actually look for life. And what do you think life would look like? It's probably microbial. It's probably little tiny things. How do you detect them? JPL already created AI that can see if something is moving against the current, against the randomness. That's very, very likely self-propelled. So we're just starting, and it's you, space builders, who is going to take us to the next step. So one experiment we did when I was at JPL is we had these big antennas, 70 meters across, 210 feet, and we wanted to optimize, could we actually find them? Could we use these antennas to point to Jupiter? And they're overscheduled. So we used quantum computing to try to see if we could actually solve the problem. And yes, we could. We also could solve it with reinforcement learning and linear integer programming. But the point is, start experimenting with new technologies, and that's one of the key trends we're seeing. We'll talk a little bit more about that. And then when you look at space, you don't have the problem of gravity. Gravity turns out to be a big problem when you're doing research. So there's a lot of things we could do on a space station, either the International Space Station or the Blue Reef or some other space station. So you can now find drugs, create new drugs, perhaps that'll help us for the next pandemic. Oh, there'll never be another one. But so a lot of scientific research is going to happen in space. And where's the universe going? Anybody know? It's expanding. Don't know why. It's going faster and faster and faster. Makes no logical sense. But there's a lot of dark matter out there, a lot of dark energy. Will it one day gravity win? It'll collapse back on itself? Again, if it happens, it's a very, very long time ago from now. But we're starting to look at that. Anybody been tracking James Webb Space Telescope? What a cool thing that is, right? Amazing. And it's at Lagrange point 2, a million miles away, and it's going to find many, many, many more exoplanets and where the universe came from. Here's a picture. If you look at the fuzzy one and you look at the new one, and it hasn't even begun. It's just still orienting itself and testing. So I think I'm going to pay a lot of attention to James Webb.
All right, over to me. So as Tom mentioned, the questions that we have about space, we've been thinking about for millennia. Are there other planets out there? Are there other beings out there? Where is the universe going? So why the focus on the space economy now? Why is now the pivotal point to be putting research and putting money and resources into the space economy? So before I answer that question, let's talk a little bit about the history of the space industry. So for decades, the space industry has been dominated by national governments. In fact, in the 1950s and 60s, it was only 2 national governments who had the resources to independently put objects into space. Now, from a technical point of view, the equipment needed to do this was ginormous. That is a technical term. Take, for example, the Mercury program. The Mercury Mission Control Centers, 2 of which were built, encompassed 2 entire buildings in the United States, not to mention several ground terminals all throughout the world. And that was only for 1 program. This is what the space industry looked like, the 50s, 60s, 70s. You start to get some other players in there, but you don't have any other independent countries until China launches Shenzhou 5 in 2003. That's less than 20 years ago, where we get 1 additional player in the industry who can independently put something in space. Now, short of 20 years later, we have short of 10,000 space companies doing something in space today. So for all of you who raised your hand and said you're doing something in space right now, thank you so, so much. The industry is changing. It's no longer just about national interest. We're looking at financial sector, we're looking at commercial sector, we're looking at humanitarian sector, we're looking at research, we're looking at exoplanets. The entire mission set has diversified so much with the new ideas pouring into the space industry. We even have a new era of human spaceflight where it's no longer just astronauts and cosmonauts. And the number of assets that are in the orbital belts right now, for those of you who have seen the movie WALL-E, it's actually beginning to look like that. So space situational awareness and space domain awareness is becoming ever more important so that we can understand what's going on not only in our planet, but out in space. And the brilliant thing about this is it now costs less than ever to do all of these amazing things. Just to give you an example of decreasing costs, let's talk a little bit about space launch. So in 1981, it cost roughly $100,000 per kilogram to launch the Space Shuttle program into space. For those of you who are a little bit metrically challenged like myself, Space Shuttle Columbia weighed a little more than a kilogram. It weighed 80,000 times more than a kilogram. Jump ahead to now. We've got Falcon 9 launching for about $2,000 a kilogram and charging ride shares of about $2,300 a kilogram. Huge difference compared to the Space Shuttle program of 1981. If we use that same extrapolation, in 40 years' time, we could have a space elevator that could take goods and people to space for roughly a few dollars a kilogram. To put that in perspective right now, a round-trip ticket in the United States on any common airline costs about $4 a kilogram. So basically, we're making space cost as much as, your next holiday to Disney World. I feel this slide is a little obvious, but I think it's important nonetheless. Who can benefit from all of these decreasing costs? Well, everyone can. So governments can use geospatial information to provide more targeted assistance. You have legacy space companies who have the opportunity to redefine themselves and redefine themselves as a company. You have universities who are spawning new research programs and new partnerships, whether commercially or in the industry, which are allowing this new group of students, this new talent, pour ideas into the space industry. Businesses are starting to use space data more and more. I mentioned the commercial sector and the financial sector. We can use space data to count the number of cars in your local shopping mall to see when people want to shop. Again, contrast this with the 1950s and 60s, where space data was solely for national security regions and national governments, and now we're able to count cars in the Walmart parking lot. We even have space data available to citizen scientists. We have space data available to all of you. If you look at some of the publicly available sets on whether AWS or some of the Sentinel data or other assets out there who are providing imagery that any person can use. And from the AWS standpoint, big technology companies have the opportunity to benefit from space as well, because it's transforming how we think of ourselves. Especially with space, we're talking about big data. Not like big data, but big data. And so it gives us the opportunity to push ourselves to think about how we manage and monetize this new huge data set. So we have cheaper cost. We have 10,000 companies. We have a whole set of new diverse missions in space. What are some of the industry trends that we're seeing from all of this? One of the first trends I want to talk about is the move away from bespoke hardware. So in the past, you had hardware specifically built for entire missions. Again, reference the Mercury program, where you had 2 entire buildings of equipment for one mission. Now we see the industry moving towards more generalized hardware that can be repurposable, use multiple assets for multiple missions. One example of this is AWS Ground Station. So AWS Ground Station allows satellite owners and operators to execute their mission without owning a single ground terminal. In addition, since we're using the power of AWS, you use the resources that you need. That means you're not paying for the ground terminal, you're not paying for the compute resources when your satellite's not overhead. Another trend that we're seeing is the use of digital twins. For those of you who haven't heard of the concept of digital twins before, a digital twin is a virtual representation of an object or a process. So think of a 3D model of an object where you're modeling out all of the operations associated with that object. So whether it's the fluid dynamics of that object, temperature, pressure control, electricity, radiation, all of that is encompassed in this virtual representation of your object. And the great thing about that is it's virtual. So now you can do things like throw an asteroid at your object, or do a failure control, or have a tube break open, and it doesn't cost you the life of that object. It's all done virtually. Hopefully it's obvious, but this makes things like innovation and iteration faster than ever. One of the companies who is doing a great job of this right now is Astra. So they have the concept of mockets, which I absolutely love that term, mockets. I think I will use it for the rest of my life. Their CEO is quoted as saying, their mockets only graduate to rockets after extensive testing, all of which is done in the cloud and at no object expense. So again, the ability to operate faster and better than ever. Another industry trend is the move to software. So a great example of this is software-defined radios. So software-defined radios, or SDRs, are modem components such as amplification, frequency conversion, filtering, modulation, error control, all done in software. Now, maybe this doesn't seem necessarily groundbreaking to all of you. In fact, we were able to do things like this in the 1990s, but we were talking about maybe a low-order modulation like QPSK and maybe a megabit per second. Now we're able to do software-defined modems for things like the DVB-S2 standard, which uses a 32 APSK modulation. That's 5 bits per symbol every time a timing cycle goes around. It uses low-density parity check codes, which are very, very good, but very, very hard algorithms to implement in software. And all of this at hundreds of megabits a second. Companies like Infinity and their SDR radio Blink are making this possible, all using the power of AWS. Another thing that we'll see in our future is satellite swarms. So in the early 2000s, telecommunications companies began rolling out fiber to personal home addresses, things like Fios and equivalent type products. Now, 20 years later, less than 50% of US households have fiber connectivity. And the internet is more important now than ever. Look at the recent pandemic, where we had to support remote learning, work from home, all based on the internet. So having reliable, fast connection to the internet is no longer a nice to have, it's a need to have. If we can't get fiber to everyone, how are we going to accomplish this? Enter satellite swarms. So these swarms, also known as proliferated constellations, create basically a fiber mesh network above the Earth. And the great thing about this is that anyone can connect to one of these satellite swarms anywhere in the planet without any private cable being laid down. So companies like Amazon Project Kuiper are going to enable worldwide internet for a humanity that honestly is dependent on internet nowadays. We even now have citizen astronauts. So companies like Blue Origin and others are investing in civil human spaceflight, which allows maybe people in this room to go to space in the next few years. So all of these industry trends are enabling space solutions that are going to help us build out the universe and solve some of our next greatest problems. Examples include satellite-enabled agriculture, where we can use satellite data to look at things like nutrient level in soil, temperature of soil, or tag things like livestock. Certainly, we still have defense and national security, and whether your beliefs roll one way or another, we can all see world events today like what's going on in Ukraine, where situational awareness is very, very vital to making sure that human lives are saved. We have new ways of doing Earth observation, so it's no longer just looking at a picture. We can overlay composites and make new and new insights from the satellite data that's coming out. And eventually, satellites are going to enable things like smart cities and digital twins for everyone.
So as I was watching that, I was thinking, Shatner as an astronaut, that's a little more than $4 a kilogram. Sorry, Captain Kirk. So now, what are some of these technology trends that will help us answer those big questions? When your grandchildren asked your children, what about, is there life out there? With these technologies, I think we can answer those questions in our lifetime, certainly in Buffy's lifetime. So here they are. These are the big industry trends, not related to space, not related to public sector, not related to commercial sector, but related to all of it. These are the industry trends that we're seeing. And we'll give a few examples of this that relate to space. At 3 o'clock, when I tell my grandchildren that, if once they grow at that age, they're not going to know what I mean. 3 o'clock? What does that mean? Everybody will have digital clocks. But if you start at 3 o'clock, environmental, social, and governance, why is that a technology trend? Because you have to prove it. You have to prove it to your stakeholders. Sustainability, that's one of the reasons for this expanding space economy. People across the world are saying, we want to save our planet. We want to prove that we can be sustainable. And when you look at Earth from space, it's very clear that the ice sheets are melting. And you can see over time that it's speeding up. So what are we going to do? So you have to prove to your constituents that you are sustainable and environmental, that you hire with equity, social, that you have a governance that can be investigated. You have to have an open governance model. And it's everywhere. These are global trends. So it's a technology trend because you have to collect a lot of data, and you have to prove it. In fact, now there's an investment, if you follow the stock market, where they're going to have to prove how much money it's a $1 trillion fund, I think, for sustainability. It's huge. So it's a big trend. Next one is local control with global security and trust. That's the only cloud trend here. What we're seeing across the world is that countries want their own GovCloud. They want something where they can prove that the data only stays in country and they're in full control. And they want them small, cheap, and disconnectable. That's a little bit tricky, but with the Ukraine situation, it's completely understandable. So that's a trend we're seeing globally. Advanced technology experiments. When we came up with these trends, there were actually 60 of them. And what we did is we talked to everybody who would listen and looked at the research, took all the chief technologies equivalents across AWS, commercial and public sector, and voted and voted and voted and squeezed them down. So advanced technology experiments is actually 10 separate trends. But the big trend is customers want to experiment with advanced technology without having to own it. The most popular ones are quantum, so quantum computing. The good thing about Bracket is you can actually don't even have to pick your quantum computer. If it's an annealer or a gate computer or simulator, Bracket connects to all of them. So, and also AWS is building its own near Caltech, where I live. So that's pretty cool. But the idea is you can start experimenting now. So when your boss say, what do you know about quantum computing? Oh, not only do I know it, we're experimenting today. The next one is blockchain. Blockchain, you have managed blockchain and you have quantum ledger database in AWS. So you can start experimenting. There's even a free tier on blockchain. So it means you can start experimenting with it. And there's all, in the Q&A, I can talk about that for too long, probably. The next one people want to know about is low code. And low code is not just for people who don't know how to program. It's that undifferentiated heavy lifting. If you can get that done automatically, why not? And AWS has Amplify, Honeycode, and now SageMaker has the SageMaker Labs. So you can get started. Another one is networking of all kinds, especially 5G and private 5G. Anybody experimenting with private 5G yet? Good, 1, 2. So when I left JPL 2 years ago, I did a deep dive on that. Figured I could replace Wi-Fi with 5G. I couldn't, because it doesn't go very well through glass and walls. Then I thought, okay, maybe we can have our own private spectrum. I talked to all of our networking people who are brilliant. They said, way too expensive, way too hard. Well, private 5G lets you do that. It's Verinder. You listen. Verinder is from JPL. And so there's a lot of opportunity to experiment and do it now. And learn, even spacecraft are experimenting now. NASA, the Mars helicopter was an experiment. It's a pretty darn good experiment, but it was an experiment. Tomorrow's workplace has a timestamp on it. It's 2 years. It's the hybrid workplace. How do we, during the pandemic, we actually became productive. We worked more hours, but we were as productive, but we weren't creative. So you all being here together in the same place, let the creativity flourish. Let those idea popcorns pop, because it's very different to be on a Chime call or any Zoom call versus being here in person. So take advantage of that. Mixed reality. Who thinks the metaverse is a real big thing, the next big thing? Raise your hands. Very few of you. Next year, all of you will raise your hands. It's not where the avatars party. It's where you do your real work. I'm going to tie that together with an example in a second. Keep that in mind. Oh, the partying is pretty fun. We built Second Life at JPL a long time ago, so if you want to hear about that, it's kind of fun. Productive at the edge. The idea there is everything is going to the edge, and it's going faster and farther, including out to space. So we're not just going to talk about Internet of Things. We'll talk about Internet of Space things, Internet of medical things, Internet of military things. And it's the network effect of everything being wireless and faster. Accessible and advanced robotics. Robots are finally really coming into their own because of these other trends. And AWS have RoboMaker and RoboRunner now, but we're seeing that being a big component. What's a spacecraft? It's a robot. It doesn't have a person on it. And then it all ties together this one mega trend we call smarter everything. And the idea there is a city is not just built to be smart. It's built to become smarter, because you have much faster networking. You have a lot cheap, very inexpensive sensors. They all collect a lot of data, put it in the cloud, where you can run machine learning and reinforcement learning on it, and then push it out to the processors at the edge that are much smarter. So now you don't even have to put the data back, because the analysis happens at the edge. So one use case here, you're sitting at home, partying with your avatars, your metaverse, with your augmented reality goggles on. An alert comes in. In your factory, there's a robot, and it's wet. It shouldn't be wet. So you click on it on your digital twin, and you see that there's a valve that needs to be closed. So you close it in the digital twin, and if it's programmatic, it'll close in the real factory. So you get complete situational awareness, whether it's a factory, a smart city, a sustainability effort. So this digital twin is the key thing to everything, because I can't think of a single use case where a digital twin would not enable everything you need to do. And you saw the Jeep out there, hopefully. Anybody see the Jeep? That's way cool. Imagine a digital twin of that Jeep driving through for a first responder, and you see the camera on the Jeep, and you see the digital twin. Amazing. Now put that in a battlefield, put it in a city. Same solution. So once you solve it for one, it'll work for just about everything, and the hardest place of all is in space. So if you can architect it for space, it'll work everywhere. Constraint-based innovation will rule the day. These are the customer segments that will change the most, and hopefully you see yourself in some of these customer segments, and we have on here why they will change. So we put government and space at the end. So government, we already talked about the ESG and trusting the government. Space, it's that much lower barriers to entry. It's 1/20th of what it used to cost. Much increased interest in space. 5 new space agencies in the last 5 years, and it's growing. And of course, the tourism. So we're now entering the era of Internet of Space things. In the next few years, we're going to launch, not AWS, but the world will launch 20,000 satellites. And so you're going to have all of these satellites. 50% of them will be looking back at Earth to provide internet access. So that means that now many, many more people will participate. As Buffy mentioned, all those interested parties. The citizen scientists can do a lot. They never had access before, but there's a lot of brain power out there. So if you enable that, and then how do you monetize it? That's a great question. And it's those questions that the next generation of space explorers will come up with. How do you combine space data with non-space data and do something creative and then monetize it? AWS has many, many ways. If you are storing data for good, it's free. If you don't know how to use cloud and want to get trained, AWS is going to train 29 million people by 2025. If you're in a startup, there's accelerators, as you heard from the keynote this morning. There's space accelerators, there's environmental accelerators, there's African accelerators. It's an amazing world, and you can all participate. Just quantum, because I like it. IDC, are you familiar with IDC, research company? They estimate that 40% of all enterprises will experiment hands-on with quantum in 2025. So is it worth learning and getting started with? Absolutely. And it's very, very large. Now when you think about, anybody in here in security, cybersecurity? Okay. Quantum encryption, future-proofing your current computing so that quantum computer can't decrypt it. Those are big areas that needs an answer. By the way, the other thing that needs an answer is how to deal with space junk. In my research, I only found one credible company, and it was Glasgow University with an internet or consumer electronics company that was working it. So that's a ripe area. We're going to have a lot of space junk out there, especially when stupid countries shoot down their own satellites. Would never happen. I wanted to show the JPL Mars rover. Anybody followed the Mars rover? Okay, so this is Perseverance. And here's its little buddy, the helicopter. So it's about the experimentation. So Mars rover, Verinder, raise your hand. And if anybody wants to know more, real, live, current JPLers sitting there. But the helicopter I was one of the sponsors of it, and it was an experiment. And the main mission did not want it at all, because it adds risk. And in space, risk is everything. So they had to go through hoop after hoop after hoop after hoop. And every hoop they passed. And now have you seen videos of it flying on Mars? That's pretty cool. So the little experiment got a lot more press than the big mission. All of the big mission is really cool. So I think it's experiment away. You have to think about not adding risk, but once it has flown, it's no longer risky. So the next mission can take it. And who are here in the startup? Raise your hands. 1, 2, 3, 4, 5. Who are in a mid-sized company? 1,000 people or less. Okay. And
Who
the rest
doesn't know where they are?
Ooh, that's a good. Are you brave enough? Yeah, we'll take pictures. But now there's a new way of traveling on foreign planets. And I mentioned Europa. How are they going to get into those craters? Maybe they fly them down. And there's all kinds. Robotics is such an exciting place right now. And RoboMaker and RoboRunner can combine drones and robots. So you can really experiment away and use machine learning or reinforcement learning to test every single combination before you build, like you were saying with the mock.
A mocket.
A mocket. A mocket. So that's what my wife is going to get for her birthday. Here's a mocket. So RoboMaker. Anybody used RoboMaker in here? 1. Okay. 2. So when we, JPL, actually helped launch RoboMaker with the open source rover, it was great. And so we could now take all of that open source and bring it into our ground-based rovers. It really saved a ton of time, a ton of money. And it let the scientists and engineers focus on the things that only they can do. And that, I think, is the key here. So if you haven't played with RoboMaker, it's fun. And it makes it easier. It's using something, the latest that all the gaming uses. And of course, the Paris Accord. Very proud of this, the fact that AWS is going to beat the Paris Accord by 10 years. And actually, 100% renewable energy by 2025. all the data centers will be run by renewable energy. Anybody has any idea how they do that? How we do it? Anybody want to know? Yes. So AWS turns out to be the largest purchaser of renewable energy. Well, what if renewable energy doesn't exist? I'll then fund somebody to go build it, and then we'll buy the renewable energy from it. So there, in the last few, I was in Stockholm just a few weeks ago talking about this, 4 wind farms in Sweden and Finland. And wherever it makes sense, sometimes it's wind, sometimes it's other things, but it's that renewable energy. Now I'm asking you this, is carbon neutral enough? I don't think so. So there's another area for you all to get creative. How do we take carbon out of the atmosphere at scale? And how do you sequester it? Because maybe we've already passed the tipping point. So that's huge amount of money are flowing. And I talked to the Minister of Finland, and she said, I have more money than I know what to do with. We're funding this, I have no idea how to do it. So there's a lot of opportunity in sustainability, monetarily. Here's 2 of them, SWAT and NISAR, very exciting satellites from NASA that JPL are running. They were running 100 times more data than anything we'd ever done before. So the cloud was the answer. And once it's in the cloud, all of a sudden, you can deal with it. Fluffy.
Yeah, so some of the trends we're seeing, just as Tom was saying, we see that data and technology is moving to being greener. We see that space data is getting bigger. I'm actually going to go back to that slide just for a second.
Please.
When we look at SWAT and NISAR, the fact that we're going to be bringing in 135 terabytes a day is amazing. But for me, the most amazing thing is that when we look at an equivalent satellite, so the SMAP satellite, the Soil Moisture Active Passive Satellite, it was launched only 6 years earlier, 2015. How many people have been employed since 2015? Hopefully a lot of people.
Wait,
Again, who doesn't know where they work? So just 6 years later, we are talking about 100 times more data. So data is getting larger. And data is getting faster. So companies like Capella Space are able to image the Earth and deliver satellite data to their customers within minutes of capture. This is compared to an average of about 24 hours in the past. So we've gone from 24 hours to deliver a picture to minutes. Think of all the things you can do with minutes of data. Because of this, data is actually becoming actionable. So companies like Exi are able to take satellite data, process it, and get it out to emergency response and emergency responders so that we can save human lives based on data being faster and therefore more actionable. So Exi in particular is able to shorten the wildfire detection to 3 minutes using AWS and get information downfield where it needs to be.
And if you live in Southern California or Australia, you're very grateful for that.
Data is also becoming combinable in ways that it's never been before. So using techniques like high-performance computing, we can analyze parallel streams of data, several thousands parallel streams of data, combine the data in the end, and come up with new insights that were never available before, such as being able to predict solar storms. All of this available on systems like AWS. So now the call to action to all of you.
Participate. So I mentioned all those space accelerated challenges. Participate. Run your own hackathons. Anybody know, just for fun, how much data is being created today? Anybody? Good. 1.6 megabytes per second per person. It's a lot of data. Only 90% of it is not processed. What is processed, 30% will go into the cloud. So all of a sudden, there are 100 petabytes of data in the Open Data Initiative that you can go out and play with. Just put your skills to work. Get your children to participate. We actually had a 12-year-old pass the SA Pro exam. I know. How about that? So just participate, and you will have some fun. Yeah, we talked about Project Kuiper already. TwinMaker, has anybody made a digital twin? Nobody. Next year, you will all raise your hand because it is such a huge opportunity. So go play with TwinMaker. Give us feedback. If it sucks, tell us. We'll make it better. If it's wonderful, tell us. We'll make it better. It's just get started. That's really the key here. And then we think that everybody will have their own Alexa, their own digital assistant. And the digital assistant can tell you, you can ask it questions. It can then spawn robotic process automation that's kind of old. But all of a sudden, if you can just talk to it, and then you spin up digital employees, they can do all kinds of boring processes. It will also tell you what you need to know when you need to know it. So I think this is, with the natural user interfaces, speech recognition, all of that. We can talk in Q&A if you want about what we did at JPL, but it was very impactful. If you can talk to it, you get 10 times faster. So I think that we will answer some of these big questions, and we can help.
So yeah, how do you get started? Come play with AWS. We try to make it easy so anyone can play with AWS. I was actually just in a talk by Orbital Insight where the CEO was talking about the fact that the largest piece of equipment that he has in his giant space analysis company is a Mac lapbook. Why is that? Because you can do all of this on the cloud. Whether you need to run a server, whether you need HPC, whether you need blockchain, if you want to play with Quantum, if you want to play with RoboMaker, you don't need to buy all of these things. You can basically rent and play with AWS, and we try to make it easy to get started. So scan the QR codes. We have a bunch of free builder skill sets out there. Web-based, lab-based, reading-based, however you prefer to learn, it's all there. And then we definitely encourage you to go ahead and get your AWS certifications as well. We now have 11 different certifications out there, and other than being able to have like the cool little button that says that you're AWS certified, it's a structured way of learning different sets of the AWS skill set, and also gives you that sort of sense of accomplishment that I am where I need to be with AWS.
And I think the key here is it's not really about AWS. It's not at all about the cloud. It's about what you do with it. One example, one of the startups last year was called EdgyBees. Anybody heard of it? Good. And so EdgyBees, they are for first responders. So let's say there's a fire with lots of smoke. They take the latest satellite images, upload it to the augmented reality, and now the firefighters can see where the street signs used to be, how many people lives in this building. So it's those type of ideas. What could you do with space data, and how can you come up with new things you can do? It's a fascinating world, and you're very lucky. I was very impressed that all of you are already working in space. So you're going to help us answer those big questions. But now we're switching to where we can help answer your questions. We have quite a bit of time for Q&A. So who's going to be the first brave person? Wow, you are a bunch of cowards. Okay, there we go. Put it on.
Ground station.
Absolutely.
Thank you. AWS Ground Station.
Yep.
So you have existing commercial customers for the ground station, antennas all around the world. How do you get more people and more antennas into your network?
So AWS is building a lot of its own ground network, right? So we own antennas right now in about 10 locations worldwide. In addition, we're partnering with customers like SES using technologies like Direct Connect so that we can tie their antennas straight into the AWS network.
Okay, what about, say, like GOCOs, government and commercial locations?
For specific use cases, it's probably best to talk to us afterwards or offline, but Direct Connect, Outpost, or the Snow family are probably going to be the 3 technologies used to get that sort of connectivity into AWS.
Okay, thank you.
But as an example there, JPL was one of the customers who helped launch that, because we needed the extra bandwidth, really. And it helped save one of our spacecraft, an experimental spacecraft called Asteria, but even so, it was remarkable. Spun up a new station in one day, so now could download twice as much data. So there's a lot of private-public partnerships there. Another question. Do you want to go to the next slide, and they can fill out there?
Yeah. How much of the economy do you see split out as people needing to put hardware in the sky versus just crunching data that may already be available or becoming available?
It's a good question. Never been asked that before. Buffy?
Thanks, Tom. Obviously, there has to be a balance, right? So the data light analysis companies can't do data analysis unless there's assets out there collecting the data. But if there's only assets collecting the data and people not actually doing data analysis, then none of those insights are actually being delivered to everyone. So there's always going to be a balance. I think the thing that's been really interesting in the past couple of years is, again, that cost to launch has come down so far that we've seen more and more low Earth operators, that's the LEO operators, put assets into space. So at least in the next few years, I imagine that there's going to be a lot of companies trying to put their own assets into space.
So the other part of that answer is, if you are in the startup, which not many of you were, but you don't have to own anything anymore. You can partner, take your skill and partner with other people. There's lots of people launching, lots of new ways. I've been asked to evaluate many new launch techniques, and they're brilliant. Taking old military planes, launching from them. So all of a sudden, you can launch faster and faster and faster and much more resilient. But there's a place for everybody, like Buffy's had that slide. So which of those pieces will be the biggest part of the puzzle? I don't know. But I don't think it's going to be the hardware. I think it's going to be everybody participating and coming up, because there's a lot more people that are able to use the data. Well, in 5 years, I'll bet you a beer, it'll be more software than hardware.
It'll be another hand raise opportunity.
Yeah. By the way, how about you guys? What do you think? It was a good question. How many people think that it's more money spent in 5 years on hardware than software? Raise your hand. How many people think there's more on software than hardware? Raise your hand. All right, good. I'm just checking you're awake. Next question.
Hi.
Hi.
At AWS, what do you see as your role in maybe the next 5-year time horizon in the cislunar XGEO domain? With XGEO space surveillance, Lone Star announcing data centers, on lunar surface as part of their plans. What do you guys see in your plan?
I haven't answered. Do you want to answer your?
Go
Okay,
ahead.
I'll go first this time. I think when I think of AWS, why I'm so excited about being here is AWS is the sea that lifts all ships. It doesn't actually build the ships necessarily, but it lifts all the ships. So everybody can now partner wherever they are across the world. It's so much cheaper to partner on the cloud, and it's faster. It's like doing a startup. You try it, doesn't work, you just stop paying. And then you try the next one, next one, next one. So I think AWS role is going to be where everybody will run their software and hardware and the innovative ideas on AWS. So I think that's our role.
I was going to give basically the same answer. I'm very, very lucky to be in the aerospace and satellite group. We have over 3,000 customers who are doing cool stuff like this all day, every day, stuff that I could never even imagine. And so I feel like my role is enabling all of the customers, everyone like you all, to do the great things out there.
And I think you said something magical there. It's something we could not even imagine. And I've been in space for a long time. The ideas that are popping are things We were hindered by our old legacy, expensive way of building things. We did cool stuff, but it's really changing. So the more things that happen, the more things will happen. That's pretty deep, very specific.
Two questions. So one, on the topic of space junk and with the cost of flight becoming so cheap, and if you look at like the new SpaceX rockets plan for Mars, that's going to open up the doors to an incredible volume of hardware that we can throw at Mars and do amazing things, but also litter the hell out of it. How are we going to manage that? And then the other side is with the age of, the other question is with the age of all this commercial space companies and agencies and organizations, where does NASA fit into that?
Good. So I'll tackle the NASA part. You want to tackle the other part?
Sure. So I'll start with the first then. So there's a lot of stuff out there. So I mentioned in my portion of the talk that space situational awareness and space domain awareness are becoming critical. We are just now sort of beginning the research and companies out there who are working on recycling space junk. So we have companies that I can't necessarily name who are thinking about ways that we can recycle some of the heavy metals that are out there. How do we get pass into space if we need to like punch through a certain belt? And honestly, going back to Tom's slide about how do we make technology greener, I think that's all going to play a part, and it's going to be a big trend, not only in space, but it's going to be a big trend really technology-wise. The entire planet is trying to do things greener, and so that's going to be a continuous theme that you hear throughout these talks, throughout space, throughout any of the industries, quite frankly.
I think on the question of NASA, I was asked all the time, is NASA worried about commercial space? Not at all. On the contrary, there is, in my opinion, nobody else's, is that if there's business to be had, business should do it. In many cases, searching for life out there, there's no business to be had. But all of a sudden, now there is space transportation. There's a business to be had. And look, it's happening with SpaceX, with Blue Origin, with others. So I think it's a very nice combination. But where it makes a difference is where, for instance, launching all these satellites. One of the things I'm really proud about Kuiper is NASA came and said, you're going to really affect our telescopes because of the brightness reflecting back. So Kuiper said, okay, we hear you, and made it so it doesn't reflect as much light. So there is light, there's a term for it, I'm drawing a blank.
Light pollution?
Light pollution, yeah. And that's good. And so everybody needs to start thinking about that, but how do you enforce standards like that? And that's where I think there's got to be a business incentive to do the right thing. The other thing is, for Kuiper, as their satellites are done, they have a lifespan, they have enough energy, just like NASA does, to orient themselves so they can crash safely into the ocean. And things like that we have to start thinking about as we get all these new satellites out there. It's a very good question. It's an opportunity for you to figure it out.
Hi, this is actually kind of related to that question in terms of space junk that someone had asked, and especially like just with your background. Do you have any thoughts on like the potential for Kessler syndrome or like, like a number of collisions occurring due to lack of space situational awareness in specific? How big of a concern do you think that actually is? And do you have any thoughts on the best way to like get more discussion about being proactive?
So I missed part of your question.
So the first part was just in regards to like the potential of Kessler syndrome occurring where like enough space debris collided with each other that it would start a chain reaction of debris that could create like even more like exponential space junk. So just as one major concern, do you have any thoughts on how to like get the conversation towards more people being aware that we need to increase space situational awareness for reasons like that?
It's a great question. I think from my perspective, that's where we need that private-public partnership, but it's not just in the US, it's globally. So I could see there becoming a United Nations of how do we manage space. It's already happening. There was a big meeting in Scotland last year where they started thinking about this. Now you have to get all the players involved, and So you need the policymakers, you need the politicians, but you also need the technical people to show them how it could be done. It's a great question. Space junk is something that is not solved yet, and it's going to get worse. So help us solve it. And that chain reaction you mentioned, yeah, it's scary.
But strangely enough, just to add on to it, and then I know you have a question as well, it's problems that we've tackled before,
Yes.
just in a different way. So like when we think about like the evolution of telecommunications, when Graham Bell first invented the telephone, it actually wasn't really very useful. Most telephones were connected to a rich person's house to their place of work, and that was it. There are 2 points, 1 line, and that was telecommunications. It was not until all of these sort of disparate little lines started to say, you know what, the world is going to be a better place if we can standardize and agree, that we allow telecommunications to touch everybody and make sort of a web sort of connection. So even though it seems far out there that the entire world's going to agree on how we govern space at some point, it's been done in the past.
And just the other thing to think about is, we worry about that, but think about all the good that's going to come from these satellites. There's one in Australia that reduced the water runoff by 95% in a very water poor environment. Increasing farming. If you go to the Cloud Innovation Center, look at the one from Korea, where they're helping small farmers. So there's all these good things that will come. So we will absolutely have to solve the bad things, but more and more satellites will launch, and it's a good thing, in my opinion.
Yeah, my question is like, we talk a lot about space here. What do you see that how space technology could play or whether it could play a role in like a green energy? Like usually we say like a solar, wind, and I'm just thinking that like in the space, it probably easier to harvest like a solar, much better, right? But is that kind of realistic to kind of say harvest the energy in the space and get it back to Earth, or what's the challenges there?
I'll start that because you brought back a fun memory. I ran a big conference once, and what I did is I took half scientists and half science fiction writers and put them together, and that came up. So how do you do it? You could have a huge laser catching it from the sun, heating a whole bunch of things on Earth, and then, so crazy, the scientists said that's absolute lunacy, and the science fiction writers said, oh, absolutely could happen. When you look at science fiction, a few years later, it actually happens. So you should do a blog on that, see what people come up with. I don't know, but it's a great question. Do you have an answer?
Well, I'll also add that, you know, we talked about finding exoplanets. We talked about finding, you know, locations in the universe where we could possibly sustain life. But part of that research is we have found a lot of places in the universe where we can't sustain life. And so although the universe is full of energy out there, you know, looking at things like solar power and stuff like that, there's also a lot of barren locations out in the grand universe where we have the opportunity to perhaps build power stations that allow less pollution on Earth as long as we can solve the transportation problem, right? So think like things like nuclear power. Everyone kind of gets squeamish about nuclear power. What if we did nuclear power on something like the moon, but we're able to get that power back?
Yeah, if we can solve that problem, NASA can do so many more things, because nuclear power in space, the spacecraft could hop between planets, piece of cake, if they could get rid of the heat. There actually is an RTG that powers all of the satellites. Very weak power, but it works. And that's why something like Perseverance is still, Curiosity is still tootling on Mars 10 years later, with no end in sight, whereas the solar panels wear out. So I think nuclear power, safe, how do you get it out of the atmosphere? You could do some amazing things.
Unfortunately, we're running into the other session time. I knew this was going to be a good conversation. So,
Take the survey.
let's thank the presenters.
Thank you very much. I called you cowards. I was wrong. You were very brave to ask questions. Thank you very much.
Thank you, everybody.
Thank you.